find the derivative of the function, take the derivative of both sides. Isolate dy dx by dividing both sides by 3y squared. You finished the problem. Let's use our basic knowledge for a more complex example. Once again, to find the derivative of a function, take the derivative of both of the sides. Isolate dy dx. Further isolate dy dx by subtracting the quantity 2x plus 5. Solve for dy dx by dividing both sides by negative 8y plus 3. You found dy dx. Now moving on to the next portion.
Find the second derivative of the function x squared plus y squared equals 1. The first step in finding the second derivative is to take the first derivative of the function, which we have already found in green, to be negative x over y. Now, to find the second derivative, you take the derivative of the first derivative. In this case, you use the quotient rule. Low d high minus high d low over low squared. Now you plug in dy dx and simplify to find your second derivative. Your second derivative is negative 1 over y cubed. That is how you find the second derivative of a function. Equation of the tangent and normal line of the function x squared plus x times y minus y squared equals 1 at the point 2, 3. The first step is to take the derivative of the function, which we have shown here. Then plug in the point 2, 3 into that derivative equation, and this solves for your slope. Next, plug in your slope into the point slope equation, and also use your point 2, 3. Simplify, and you have found your tangent equation. The next step is to find your normal line equation, which all you have to do is take your slope that you had found, change it to your negative reciprocal, re-plug that into the point slope equation with the same point at 2, 3. Simplify, and that is your normal line equation.
The power rule is used to easily find the derivative of a power function. Let's find the derivative of a basic power function x to the 9/4, using the formula above in green. To To apply the rational power rule to a root function, change it to a power function first, and then solve according to the rational power rule. To apply the rational power rule to a quantity power function, we must remember outside, inside. And simplify.